Good evening, everyone. Let's start the class for today. Okay, so we'll start our class with this. Uh, okay, so today we'll be having your tutorial session for week 6 assignment. The previous year questions that were given in the assignment for week 6, we'll be discussing those questions in today's class. And I hope you all must have attended the old video lectures in your NPTEL coursework that are being given by Professor Gujar. So, am I audible? Can anyone please confirm that because I'm getting no response from you guys.
The sound is quite low. Can you increase the volume?
Okay, is it fine now?
Ma'am,
Okay, okay. I'll keep that in mind. So, starting for our assignment for week 6, the first question is that what is the curbside location? And the options are option A, side of the water body, option B, side of the pavement, option C, outside the main city, and option D is away from the pavement. Basically, I guess this question is from your case study, and those who are having a civil or transportation background, they must be familiar with this term, this curbside location. Anyone in the class who knows this term? Can you please repeat, Harsha? I couldn't hear you.
I I don't know the meaning of this word, ma'am.
Okay, okay. Anyone else? See, this is a very familiar thing. You all must be knowing this. It's just the technical term that is confusing you guys. Okay, let me show you the picture. You all will be identifying this. You all must have seen this point now, this part of the road, which is slightly raised, and this separates your footpath or the side pavement with the main road, like this one in this picture. Have you seen this?
Yes, ma'am.
Okay, so this raised edge of a pavement which separates it from the main road, this is termed as your curb. So basically, excuse me, I'm getting a call. Just a second. Yes. So this curbside location, it is found on the side of the pavement. Correct? Got it, everyone? I hope everyone must have seen this thing. Now, from the next time you just see a road, then you can be able to visualize this curb, which is the raised edge of a pavement. Okay, so next question. Which of the following models is used in the bottom-up approach? Positive mass factorization, PMF model. Next is your chemical mass balance, CMB model. Next is your Lagrangian model, and next is principal component analysis. First of all, tell me this bottom-up approach. What does this refer to? And which topic is it related to? Anyone? Okay, fine. I have added the slides from that lecture. and we'll be discussing this bottom up and top down approach, and just a, we'll be having a just quick review on these topics. So basically your source apportionment approaches, basically there are two fundamental approaches for the source apportionment studies, and those are your bottom up or source based methods, and next is your top down or receptor based methods. So what is your bottom up or source based methods? Basically, in this method, what we do is we begin with the identification of your emission activities or the pollution sources, and then we estimate the total pollution advection, basically how it moves over the over the time and space, and then we formulate your total emissions. That is your bottom up approach. Basically here we focus first on the sources and then on the total amount of emissions.
Ma'am,
So
what
what,
is the meaning of emission strengths, ma'am? It is given in that PP slide.
which term?
Emission strength.
Emission strength. Okay, and their emission strength is basically the total amount of emission that a particular source can generate. That is its emission strength.
Thank you, ma'am.
Next is your what are the results that we obtain from this bottom up or source based methods. So here we get to identify the potential sources in any particular area. What are the potential sources of the pollution? We are able to identify those. Then we describe the different physical and chemical process by which these pollutants can be dispersed in the nearby areas. Then we can bifurcate the total pollutants into both primary and the secondary pollutants. Then after that, uh, when we know the sources, then we know the process of their dispersion, then we can be able to identify the different pollution hotspots or the regions which will be having a higher amount of pollution as compared to the nearby areas. So those are termed as pollution hotspots. We can definitely mark those hotspots in our map of that area. And then last one is your apportionment of the pollution by source, which source will be creating how much amount of pollution and what type of pollutants are expected from that source. That is the result
Ma'am,
that
what is
we.
the meaning of baseline mapping, ma'am? Baseline mapping is given in this slide.
Okay, baseline mapping is nothing just that your mapping of the flow of the pollutants, how these are moving from starting from the source, and what will be the different level of pollutants in different areas that we are considering for your source apportionment studies. That is your baseline mapping.
Thank you, ma'am.
Okay. So we'll be defining these terms in a bit detail. First is your identification of your potential sources. So basically, what we do is now for our source apportionment study, we consider a specific area. For example, we have taken this much area here. Now, what will be the potential sources that are present? Like for example, if there is some road, then definitely there will be some emissions on the road due to these vehicles, this road. So this is a source of pollution. Next, if you are having any industries like in this one, industries will be another source of pollution. Next is your office spaces or buildings. They are also some sort of potential sources, or if any kind of activities are going on in those regions. And next is our point of interest, like this point. We are interested in the level of pollutants for this region. Just a second. Uh, weird. Okay. we'll be interested for this region. So for this region, what will be the level of pollutant that are being transferred from this road, transported from this road, then this building, and then this factories? What are the impacts or the level of pollution that is being dispersed from this to this place? That is your source apportionment thing. And potential sources, the first step is your identification of potential sources. Next is the description of the physical and chemical process. Basically, here with respect to the potential to impact the advection and chemistry of the pollutants, what are the physical and chemical process that are affecting your transfer of these pollutants? These can also include your local topography and your meteorological features, like what kind of climatic conditions are prevailing there, what is your wind movement, and how is the topography of that area. If there are some undulations or some hill is there, then it will hinder the wind movement. So that is also one thing that we need to know. Next is your documentation of primary and secondary pollutants. So like along with the primary pollutants, we also need to know about the formation of the secondary pollutants, and that we also have discussed in the emission inventories now, like what kind of primary and the secondary sources are there. Next is your baseline mapping. So it is a baseline mapping of the pollution and the hotspots for the area of interest, as explained previously. And some of the models that are for the source-based methods. These include your Gaussian and Lagrangian models. So Gaussian plume model, that we'll be discussing in a bit detail also in the I guess in the coming classes, and will also be having some numericals for these Gaussian plume models. And this type of model is often used to estimate the emissions from the industrial sources. And then we have your Lagrangian model. It uses a moving frame of reference. Either here Gaussian plume model assumes a stationary frame of reference, and it is uses a moving frame of reference. Next, we are having your equations for your Gaussian and Lagrangian model. You'll be studying these in your coming classes. No need to discuss now. Okay, so what are the advantages of these source-based methods? So first is you're locating the pollution sources through the development of emission inventories. We are able to identify the potential sources for the primary emissions. Then we are able to describe the like physical characteristics that affect the ambient level of the pollution. For example, your meteorological features, your climatic conditions, your terrain features, and then the chemical processes that influence the pollutant levels like advection, diffusion, and dispersion, and also which the process which include the formation of those secondary aerosols. These are also there. Then we have our bottom up or source based methods advantages. Uh, okay, again. So documenting the potential for secondary aerosol formation explained before. Then you'll be able to identify the sources that would be most effective in controlling and affecting the ambient levels the most. Basically, see, if we are having multiple sources of pollution, then it's not necessary to control each one of them. Basically, there will be one or two or more sources which will have the major impact on the air quality. So we'll be able to identify those sources, and if we are able to control the emissions from those sources, ultimately the air quality will enhance. And also it provides us some spatial coverage that how sources impact the air quality and exposure. Basically, will have a level of pollutants for at different points in, for example, if we have this area na, so we'll have at different points what will be the potential sources. We'll be able to identify that. So if a, like for example, if a source is present here, So for this source, what will be the level of impact at different locations, we'll be able to identify that. This is termed as your spatial variation. Now, we also have some disadvantages of these source-based methods. Basically, uh, first one is your if you when while we collect the primary data to determine the emission factors by fuel and sector, the requirement for the laboratory equipments are quite high. Then next is your the emission inventory work is heavily dependent on the depth of activity levels, fuel consumption data, and emission factors, which can vary region by region. So it is quite possible that the data that we generate is erroneous or it has some errors also. And then the staff that is required should be experienced to analyze or map the emission inventory for such study region. So these are the disadvantages. Now coming towards our question, I guess most of the students have got some idea about these bottom-up approaches. Okay, so which of the following model is used in the bottom-up approach? We just discussed two models that are there for this bottom-up approach. Anyone?
Lagrangian model, ma'am.
And the next one, other model that is there for the bottom-up approach?
And Gaussian plume model.
Correct. Okay, so moving towards the next question. Okay, so top-down approach is also known as, earlier we discussed the bottom-up approach. Now we are going forward to the top-down approach. So this is also termed as receptor-based method, source-based methods, emission inventory-based methods, and dispersion-based method. Which one is there?
Receptor based method, ma'am.
Yes, correct. So quickly we'll have an overview about this top-down approach as well. So basically, this is just the reverse case of your bottom-up approach. Here we begin the source apportionment by sampling the air quality in a given area. Like we take samples of the air at different spots in a given area, and then we infer the likely pollution sources by matching the common chemical and physical characteristics between the sources and the air pollution samples. Basically, here we target first the pollutants and then we go forward towards their potential sources of emissions, right? So, what are the results that we get from this top-down or receptor-based methods? First is your identification of the hotspots with critical pollutant levels in the city or the region. Since we are taking air samples from the different points within a city or a region, so we will be able to identify the hotspots, basically those places which will be having like extremely high level of pollution. We'll be able to identify those places. Next is your identification of the chemical composition of the particulate pollution following the chemical analysis of the measured samples. Basically, since we are having different samples, so we'll be doing the chemical analysis for those air samples, and then we'll be having your chemical composition of those pollutants. Next is your description of the source impact is estimates following the receptor modeling. And then differentiation of the primary and secondary pollution at the hotspots. And last one is the apportionment of the pollution by the source. So first step is that this identification of the hotspots with critical pollution levels in the city or the region. This one. Then we go for sampling, identification of the chemical composition of the particulate pollution. This thing like sample collection and measurement, then your chemical analysis of the samples measured. Then we do the receptor modeling thing. Basically, we describe the source impact estimates following receptor modeling based on the source profiles and statistical analysis. basically we have different sources that are present in a region, and then we we got to know about the different pollutants at different places. Then we do this receptor modeling thing to identify the, like, which source will be emitting which kind of pollutants, and different models that are there for your receptor based methods. First is your chemical mass balance, CMB, model. Then next we have your multivariate method, or the positive matrix factorization, PMF model. Then, okay, we have discussed these two methods. Now the advantages for your top-down or receptor-based methods. First, it determines if the selected monitoring sites or hotspots exceed the compliance levels. Then, it also identifies the critical pollutants of concern, the pollutants that are in extremely high amount in the atmosphere, and the pollutants that are needed to be taken care of. So we get to know about those pollutants through this method. Then we may differentiate the chemical composition of the particulate matter, for example, the primary and the secondary contributions. Then it describes the source impact estimates. Next, it also identifies the sources which will be most effective to control. And the last is your the uncertainties that were included in the bottom-up approach. Those are avoided in this top-down method. Now, it also has some disadvantages. So the need to have and apply appropriate source profiles which match emission sources with ambient air pollution. It's not necessary that every time will be having a correct match for the source profile and the emission inventories. Next is in some cases we are not able to differentiate sources that have a similar chemical composition, and those sources are known as collinear sources. For example, if we are referring to cooking in the fire, and also open burning, those will have both will have similar type of emissions. Or for example, resuspended road dust and soil dust, both will have similar characteristics. So it's difficult to classify between or differentiate between these type of sources, and thus this method is not able to fully account for possible non-linearities, and which is due to the formation of secondary aerosols. So these are the disadvantages for the top-down or receptor-based methods. Now, if we integrate the bottom-up and top-down approaches, then bottom-up methods pose significant technical challenges in terms of your technical expertise, time, and money for developing accurate bottom-up emission inventory and an atmospheric model that agrees with ambient measurements. Basically, the drawback of bottom-up method is that we need we have been facing significant technical challenges, and this is this problem is solved by using the top down methods, basically, because these allow for useful information to be gained from relatively few ambient measurements. We don't need to go for that much measurements. Then your top down methods can identify the relative contributions of different sources categories to the particulate matter problem. This information can be utilized to improve the bottom up analysis, and thereby a region's air quality management system. And thus the interaction of both the methods, it forms an iterative process of learning through which the sources of air pollution can be more precisely quantified. So next question, the fundamental principle of receptor modeling is mass conservation. The fundamental principle of receptor modeling is, first is your mass conservation, next energy conservation, normal distribution, and conservation of momentum. Uh, okay,
Mass
so
conservation.
True, mass conservation. It will be mass conservation only. Let's go through the basics. Okay, so your receptor models are statistical tools that are used to identify the sources of your air pollutants and then quantifying their absolute and relative contributions to the pollution load. The basically what we are doing here is, first we are identifying the potential sources of your air pollutants in an area, and then like what are the total emissions that are being generated from those sources, or the pollution or their contribution to the pollution load at a certain receptor location which is away from that source. So this is your receptor modeling thing. Then these use the chemical and physical properties of gases and particles, which are measured at the source and receptor to both detect and quantify the presence of source contributions. Then what do these receptor models do? Basically, these apportion the measured mass of an atmospheric pollutant at a given site, which is termed as the receptor. And the fundamental principle of this receptor modeling is the mass conservation between the emission sources and the receptors. Basically, we assume that in these receptor models, we assume that the total mass of the pollutant remains conserved. Basically, the amount that is being generated from the emission sources and the amount that is received from different receptors, that is the same. The total mass of the pollution or the pollutants remains conserved, and this is your mass balance equation, which is used to identify the sources. And in order to find the solutions, a data set with a rather large amount of data consisting of chemical constituents is gathered from several samples. For example, you can see here like different samples are there, and we have different types of pollutants that are there. And the larger the data matrix, the higher the chances that the model will identify the distinct factors that can be identified as sources. So this is your receptor modeling. Now coming towards the main characteristics of the receptor models. First is chemical mass balance principle. Next is based on the solution of multilinear equations. Next is these do not depend on emission inventories. So and last one is all of the above. So what are the main characteristics of receptor models? Let's see that. So first is these use measured concentrations at the receptor end. These use measured concentration at the receptor end. Then these also refer to the chemical mass balance principle. Then these are based on the solution of multilinear equations, and these do not require complex metrological and chemical process. Basically, these are a bit simpler process as compared to your based methods, and these thus they require low computational intensities and mainly used on particulate matter emissions, and thus they are appropriate for your urban and regional scales. So I guess for this we have all of the above. Okay, so now this is some kind of matching thing. Let's see. Okay, so these are the type of pollutants. We can say these three at least: organic carbon, organic elements, and organic compounds. And here we have different methods that are there. So let's see. Okay, so for your organic carbon and elemental compounds, Either total or by single temperature steps are commonly measured using thermal optical methods. So we have for organic carbon, we have your thermal optical methods. Okay, see this thing now. We have 2 for A, then definitely D will be 3, right? Now we are left with B and C, inorganic and organic compounds. Now let's see. For inorganic elements, inductively coupled plasma mass spectrometry, ICP-MS, this one. This is for your inorganic elements. That means B is 4, this. So answer will be this. No need to even see the C1, but still the organic compounds will be found using this high performance liquid chromatography. Got it? Okay, so next question. Which of the following is not the cause of indoor air pollution? First is your poorly designed ventilation systems. Next is well-designed ventilation systems. Next is indoor sources of air pollution, and then outdoor sources of air pollution. So which of the
Well-designed
following?
ventilation system.
Yes, not the cause, because we are clearly seeing here is not the cause. So definitely these three are the causes of the indoor air pollution. Okay, so coming towards the causes of the indoor air pollution, basically, see, just a second.
Ma'am, you are on mute, ma'am.
Yes, sorry, I just got a call. Okay, so what are the causes of the indoor air pollution? Basically, like the all the causes are being bifurcated into these four parts. First is your air tightness of buildings. Next is your poorly designed air conditioning and ventilation systems. Then we have indoor sources of air pollution, and then outdoor sources of air pollution. So we'll be taking all these causes in a bit detail in the class. So what are the pollutant sources? Basically, the indoor air pollution sources that release either the gases or the particles. Gases, for example, your carbon dioxide, carbon monoxide, and the pollutants, for example, as PM10, PM2.5, even PM1. So these are the pollutant sources that release the gases or particles into the air, and then thus they are the primary cause of indoor air quality problems in our homes or office spaces or any kind of indoor environments that we are considering. Then the outdoor sources of the pollution, these also affect the indoor air quality. And then we also have sources such as building materials, furnishings, and household products like air fresheners. These also release the pollutants in in lesser or more amounts. So first is your air tightness of buildings. Basically, airtight houses or buildings can have an hazardous impact on the indoor air quality, because if we are having any type of potential sources of the pollution inside our buildings, and then if they are airtight, then what will happen is the level, see, if there's no leakage, like if this wall is such that there will be no leakage, of the air, then what will have is, if we have some potential source of pollution P, it will tend to increase its level. And since it's not properly ventilated, or this building is airtight, what will happen is this level of pollution P, it will start spreading throughout the building. It will go this, it will go upwards, and then the entire building will be affected by this pollutant, and thus it will have an hazardous impact on the indoor air quality. Then your reduction of the ventilation rates, that will improve the energy efficiency and lower carbon emissions without providing a planned and effective ventilation strategy is like to result in a more toxic and hazardous indoor environment. Basically, what we why do we reduce these ventilation rates? We tend to reduce this rate of ventilation just to improve the energy efficiency of the buildings. We need to capture those energy that is being generated inside this building, and also to reduce the carbon emissions. But since this is not a planned strategy, thus it will lead to a more toxic and hazardous indoor environment. Also, it will also lead to development of negative pressure inside the building. And due to this negative air pressure, what will happen is, the air that was supposed to be moving outside the building, it will start moving inside the building. So the pollutants that are like in the nearby region, they will also start entering the building. So this positive and negative air pressure, does these terms mean? Basically, if the air pressure inside the environment that we're considering is more than the pressure outside, then this is termed as your positive air pressure. And in such conditions, the air present inside the building, it starts moving outwards. And when the negative pressure is there, a suction is created. And in this condition, the air pressure inside is lower than the pressure outside, and thus the air outside air rushes in and try to balance out the pressure difference. Now we have your poorly designed HVAC system. So if we are not cleaning or properly maintaining our HVAC systems, then due to the presence of that moisture and dust and due to the presence of different pollutants in that, it leads to the production of your fungi and molds and other sickness causing microbes that are being generated in these HVAC systems. And when they are operated, they are released into those indoor environments. This thing you must have been observed in some places where there's centralized AC systems, and the AC ducts are not being properly cleaned or maintained. Then you tend to notice that if you enter at some spaces, there is a some kind of smell of that moisture, or some kind of how do I explain, development of fungus or something is there. You tend to have a strong smell just by entering in those micro environments. So that is due to this poorly designed HVAC systems. Now we'll be looking forward towards the sources of different sources of the indoor air pollutants in your households, and then also we'll be taking a typical office building also. So in your houses, we have your bathrooms, we have your air conditioning units, then we have living rooms, then outdoor air, your bedroom, your laundry room, and your kitchen. So we'll take each space one by one. So in your bathroom, since a lot of moisture is there, so we'll be having your molds, your mildew, your odors, and also microbial pathogens. Like the bathroom tends to have large amount of pathogens in it. Then if your air conditioning units, these are not properly maintained or properly serviced on time, then these are unable to remove the pathogens, and in some cases they also emit some of the VOCs and odors. And thus if we are using your ACs, then there's not much ventilation in the rooms. Then in your living rooms, if we have pets, then we have their animal hair, dust and dander. Then if someone is smoking, then we have the sources like, for example, tobacco smoke, second-hand smoking. Then VOCs from paints, varnishes. Then your upholstery from in the furniture, that is also a source that it captures a lot of particulate matters. Then your carpet, that also tend to collect a lot of dust. Next is your outdoor air. If it will have some amount of particulate matters, pathogens, and VOCs, then it can also enter inside our houses. Your bedrooms will have emissions as VOCs from perfumes, hairsprays, nail polishes, upholstery, furniture, and carpet. Then your bed sheets might have dust mites. Then your laundry room can have VOCs from cleaning supplies. Then mold, mildew, odors, and other microbial pathogens can also be there, because it's because it will be having some amount of moisture. And then in your kitchen we'll have emissions during the cooking processes, and also the type of fuel that we are using for the cooking practices. Now, next is your sources of indoor air pollutants in a typical office building. So, first is your carpet. It can have VOCs, formaldehyde, and then if we are using some amount of pest control or some kind of spray in the environment, then it can also have some emissions. VOCs are also emitted from your paints that we are using in the wall. Then the printer in the office, that also have some amount of emissions. If someone is sitting there and he or she is using some kind of perfume, then some of the VOCs are present in that environment. So that is there. Now, these are the potential sources of the contaminants in any indoor environment. Like, first one is your outside building, the sources that are present outside. Next is your equipments that we are using. Then we have the chemicals that are being released from the buildings. For example, some kind of building materials use asbestos, that is a major source of pollutant in some cases. Then your indoor human activities such as cleaning, cooking, or some other activities as well, they also tend to produce some emissions. For example, smoking. Then your building components and furnishings, these tend to behave as a how do we say, like your building material and furnishings that are there to capture those pollutants, and the pollutants tend to accumulate on them if not cleaned properly. Then your sources outside the building, first is your the air gets contaminated by the pollens and dust. Next is your industrial pollutants, and also then we have your general vehicle exhaust. Then the nearby sources that include your parking lots and garages. Then odors from dumpsters, then re-entrained exhaust and unsanitary debris. Next, if we have your seepage or the soil gas, then if we have constructed our houses or our building in some place where previously it was used as a landfill site, or some amount of some site that has the large amount of pesticides and etc., then it's possible then that the pollutants tend to seep in from those places towards the our building, inside our building. Then we have moisture, like the rooftops after the rainfall or the crawl space. These tend to serve as the major source of your moisture, and which will create like bacterial growth, and they will ultimately lead to the growth of pathogens. Next, we have heating, ventilation, and air conditioning (HVAC) systems, and it will have dust in ductwork, microbial growth in drip pans, humidifiers, then improper use of biocides and sealants, and improper venting of combustion products. And if you are using non-HVAC products, then we have your emissions from office equipments and supplies, cleaning process, elevator motors, and other mechanical systems. Now, your human activities, these include your maintenance activities. For example, VOCs can be released from the use of these paints, adhesive, and other products. Pesticides can be released from your pest control activities. Then for the housekeeping, like materials, cleaning supplies, if you are using some kind of sprays or cleaning disinfectants or some other things, then they can also release some pollutants. Then we have your emissions from stored supplies, use of deodorizers and fragrances. Then your human activities, like personal activities, for example, smoking, cooking, then your body odor or your cosmetic odor, that also tend to create some of the other pollutants. Then your building components and furnishings, for example, the locations that tend to produce, either produce or collect the dust. For example, your textured surfaces such as your carpet and curtains, these tend to collect a large amount of dust. Then your open shelves, then your old and deteriorated furnishings, materials containing damaged asbestos. Then we have your unsanitary conditions, for example, microbiological growth on or in soiled water or water damaged furnishings, for example, this area. Here you can see a lot of moisture is there. Also, this blackening of this place, this shows a development of fungi or some kind of bacterial growth is there. Dry traps that allow the passage of sewer gas, that is also some kind of unsanitary condition. Then we have your accidental events, for example, spills of liquids or the microbiological growth due to flooding or to leaks from roofs, piping, fire damage. These also tend to have some sources of the pollution. Then during these repair activities, what will happen if we are tend to if we tend to have some kind of maintenance or repair activities in our indoor environments, then a large amount of emissions are also there. For example, emissions from new furnishings, then your dust and fibers from demolition, then odors and VOCs and inorganic compounds from paint and adhesives. Then you have microbiological contaminants that are released from demolition or remodeling activities. So these are the major sources of pollutants in indoor environments. Next, we have which of the following indoor air pollutant is responsible for the irritation to the skin? First is SO2, second is NOx, third is your respirable suspended particulate matter, and last is your carbon monoxide. Okay, so NOx is the one. Basically, the health effects that are associated with nitrogen dioxide, low level of NO2 exposure that may cause your increased bronchial reactivity in some asthmatics, and then your decreased lung function in patients with COPDs, then increased risk of respiratory infections, especially in young children. NO2 also acts like if we have acute toxicity, then we have irritation of the respiratory tract, toxicodema, emphysema. These are some of the like diseases that tend to have due to higher exposure to oxides of nitrogen. Then continued exposure to high NO2 levels can contribute to the development of acute or chronic bronchitis as well. And what are the steps that we can take to reduce these exposure to nitrogen dioxide? First is your keeping the gas appliances properly adjusted. Next is your consider purchasing a vented space heater when replacing an unvented one. Next is your use of proper fuel in kerosene space heaters. Then installing and using an exhaust fan vented to outdoors. Basically, if we want to reduce any kind of gas in a closed micro environment, the best way is just to increase the ventilation. Only by increasing the ventilation we can reduce these emissions to a significant amount. Then we have open fuse when fireplaces are not in use, and then do not idle the car inside the garage. That will also lead to increase in the NOx levels. Next is, what is the source of asbestos in the indoor environment? First is your building maintenance, next is glue, next is insecticides, next is fertilizers. So this building maintenance, it leads to a high level of asbestos in the indoor environment. So basically, what is asbestos? Asbestos is a mineral fiber that occurs in the rock and soil, and since it is having a high fiber strength, it has been widely used in a variety of buildings and construction materials, and also as a fire retardant. But after some time, it was observed that these fiber tend to get separated from this material, and they can if we breathe, they tend to get accumulated in the air, and then during the breathing process, when we inhale the air, these fiber mm, get inside our lungs, and these are very harmful for the lungs. And in general, exposure may occur only when the asbestos containing material is disturbed or damaged. Basically, it needs some way to release the particles or the fibers into the air. And basically, the sources of these asbestos, these include that it can be released into the air by the disturbance of asbestos containing material during the product use or the demolition work, building or home maintenance, then repair and remodeling. It has also been used in a wide range of manufactured goods, mostly in building materials. For example, these sheets that are being used in the rooftops, earlier these tend to have asbestos in them. Friction products, heat resistant fabrics, packaging gaskets, and coatings. All of them used to have asbestos in them. Next is your, which of the following are the sources of biological indoor pollutants? First is your mattresses, next is your pitch blende, then you have disinfectants, and then uranium. Which of the following sources will have biological indoor pollutants? Anyone?
Disinfectants, no?
Disinfectants, these will have more of VOCs, not the biological pollutants. Basically, let's see.
Mattresses, no?
Yeah, okay. So, what are these biological pollutants? We have your animal dander, dust mites, molds, infectious agents, and pollens. These are the biological pollutants that are generated in different indoor environments, and the sources are, first is your water damaged surfaces and materials. Next is your humidifiers and stagnant water. Then we have water vapor from cooking and showering. Next we have your air conditioning systems, and then mattresses or upholstered furniture and carpets. And then we have dirt. So mattresses are the source of biological pollutants. So dust mites. Basically, what is dust mites? So these feed on human dander and prefer warm and humid environments. And the sources are your bedding, carpets, upholstery, and soft toys. These tend to have dust mites in them, and to prevent these dust mites, what we can do is we can encase our mattresses and pillows, washing bedding in hot water, then frequent vacuuming or damp mopping of these areas. Then also by decreasing the clutter, we can reduce these dust mites, and then removing the carpets. Next we have animal allergens. So we have cat dander, which is most allergenic. Then we have dog dander, birds, cockroaches, parts and feces. Then to like to prevent these animal allergens, we can simply remove animals from indoor environments and tend to settle them in some outdoor environments. And allergens persist for many months after the removal of source. So we have to clean the environment and pets frequently, and then also we should have adequate ventilation in our environments. And next we should control the dust and moisture in these environments. Now, for molds, a frequently undetected environmental problem is the development of this kind of molds. It can be easily seen in any house which has some kind of seepage or some kind of moisture from outside environment. And these occur in damp indoor areas, and this will lead to allergies and non-specific symptoms. But it's very rare to have infections from these molds. And the chemical agents produced by molds are mycotoxins, which are associated with human disease and can cause acute and chronic effects. So that is it for today's class. And if you guys are having any doubt, then we can take that.
Ma'am,
Is there any?
I basically have a simple doubt, ma'am. So, bottom up approach means that we from the source we start and then we go to the source characteristics, ma'am. And for top to receptor based method, we go from the source characteristics to the source. Is this correct, ma'am?
Yes, basically in bottom-up approach, we first identify the potential sources and then move towards the total emissions. And in the top-down approach, we first get to know about the emissions. First, we do is the air. What we do first is the air sampling, and then we move forward towards the sources. That is your top-down approach.
Thank you, ma'am. If we start from the pollution sources and we go to the emissions, then it means it's a bottom up approach. Correct, ma'am?
Correct.
Thank you, ma'am.
Anyone else?
But for both top down and bottom up, we use receptor models, ma'am.
No, for bottom up, we use different models. For example, like your Gaussian and Lagrangian models. And for your top-down approach, we use receptor models.
There's a problem in lecture 28 about receptor modeling, ma'am. The formula is a little difficult to understand. So can you explain that?
Which lecture, Harsha?
Ma'am, lecture 28, ma'am.
Lecture 28. Just a second. I'll share the slides for lecture 28. Okay, is it visible?
Ma'am.
Okay. Uh, just stop me whenever you get that formula, na?
Yes,
This is
ma'am.
your basic, this formula or some other
No,
formula?
ma'am. By the end of this lecture, there is a problem, ma'am.
Okay, let me see.
This one, ma'am.
This one? Okay, so this is a basic example of your receptor modeling. So in the question, what they have given is we have two metals from two sources. Okay, soil dust and steel plant. Basically, soil dust. Okay, we have your like calcium and iron, right? These
Yes,
two are
ma'am.
being emitted from your soil dust and steel plants, and the total emissions are given as 50 microgram per meter cube, and for iron it is 15. And we have to calculate the pollution contribution of each of the sources in ambient area, and also which source is needed to be controlled. Okay, fine. So we'll be using your mass balance equation for both the like pollutants, for calcium and for your iron as well. Fine.
Yes, ma'am.
Okay. So let me first explain you these terms from the mass balance equation. It was in the starting already. This is your mass balance equation. Basically, here Xij is your concentration of the jth species in the ith sample. Xij is nothing but the concentration of some pollutant that we are considering here. Okay? G is the contribution of the source, kth source, to the ith sample. That sample which we are considering here. G is its contribution and F is the concentration of the jth species in the kth source, right? And here E is your residual term which is not given in the question, so we'll be considering this G and F, correct?
Yes, ma'am.
Contribution and the concentration and its summation. So let's move towards our question. Okay. So G is your concentration and F is its sorry, G is your contribution and F is your like concentration, right?
Ma'am.
Okay, yes, F is your concentration and G is your contribution. So for your XCA, first we multiplied GCA of steel with F of steel. Like concentration in steel is multiplied by contribution of steel plant in the emission of calcium, right? And
Yes, ma'am.
similarly, we have your total emissions from your soil source, soil plant, like F soil, which is multiplied by contribution of this plant, like contribution of this plant in emitting calcium, GCA of soil plant, right?
Yes,
We
ma'am.
are taking both the plants, F steel and F soil. These are the total emissions from these two plants, and GCA of steel and GCA of soil, these are the contribution of these plants in the emission of your calcium. Similarly, we have the equation for iron, right? And in the question, it is given the total emission of your calcium and iron is 50 and 15. So we are like we have values of XCA and XFE. This XCA is 50 and XFE is 15, right?
Yes, ma'am.
Then we have GCA of steel 0.2, GCA of soil 0.9, GFE of steel has 0.8, and GFE of soil has 0.1. By putting the data in these two equations, we get this equation. Now we just have to do one thing. Either you can do like simple by multiplying this term by 4 and then subtracting. Basically, we need to solve these two equations somehow to get the value of this F steel and F soil.
I can understand. Thank you, ma'am.
Okay. I hope you got that.
Yes, ma'am.
Okay. Um, any other doubt? Anyone?
Ma'am, someone has asked about final paper pattern, ma'am. Ma'am, you're on mute, ma'am.
Sorry. Actually, I was saying कि this will be of your multiple choice question type paper, and like it won't be very difficult for you guys because the topics that you have covered in the class and your assignments, only those will be given in the paper, not a very difficult one.
Yes, ma'am.
Anyone else? Any
Ma'am,
doubt?
in Friday, sir, Rupam sir discusses very complicated problems. So, can we? Will they appear in our final exam, ma'am?
See, I don't think very if you will be having very complicated problems in your paper, or else I can do one thing. Like this week only, I'll analyze your previous year question paper that were given to you, and then I'll tell you about the paper pattern, like what kind of questions you'll be expecting in your examination. Is that fine?
Yes, ma'am. That's
Okay,
fine.
I'll just check the examination papers that were given in the previous year. Also, I'll discuss with the TAs that will be making your question paper, like what kind of questions they'll be like giving to you.
Ma'am. Thank you, ma'am.
Okay. Okay, so I guess if you're not having any doubts, anyone else, if if you are having any doubts, please feel free to ask, okay, in the chat box. Now
Ma'am,
we have
one last
some.
third term. So this chemical mass balance, I don't understand the term itself, ma'am. So can you please explain that chemical mass balance, ma'am?
See, basically, mass balance equation is just like see if we have some inlet and some outlet points. So it is the basic assumption whatever amount of pollutant is coming from that inlet, same amount is being delivered from that outlet. That is your simple mass balance model. And if we are considering this model in terms of some chemicals or some of the pollutants, then it is termed as your chemical mass balance.
Thank you, ma'am.
Okay, someone has asked that we have not submitted our first six assignments. Now we are unable to submit. Uh, it's Muhammad Saban Kant. See, I don't think you'll be able to submit them. I guess the deadline is for like for that week only, na, for submitting the assignments. I guess you have to submit those assignments weekly. I don't think. But anyway, I'll check this with the TAs or the coordinator of that course, and I'll ask them, and then I'll let you know that if you can submit or not. Okay, anyone else?
Lecture 26, they have given the grid-based models and hotspots and complicated. About Delhi, they have explained, ma'am. So, is this very important for the final exam?
No, see, this is some kind of case study. It is just for your understanding point of view that how to generate an emission inventory. Basically, they have taken a case study of the city of Delhi, and they have tried to formulate an emission inventory, and the whole process is defined to you. So, like, you just need to have an overall idea about creating an emission inventory, because since you'll be having your MCQ type of questions, so they won't they won't ask you to develop a whole emission inventory, but some part of the or the other that can be asked in the exam.
Thank you, ma'am.
Okay, Harsha.
Excuse me, ma'am.
Yes.
Ma'am, I am unable to submit my first six assignments.
Yes, I've read your message in the chat box only. I'll just talk to your coordinator, and we'll let you know. Maybe I'll just answer your query in this chat box only. Just give me time for one day, and I'll let you know.
Okay, ma'am. Thank you, ma'am.
This receptor model, so there's a source and there's a receptor, ma'am. So if a car is the source, then the receptor, we can say it is a human being. So uh, is that correct, ma'am?
Yeah. The receptor can be anything. Like it can be at some area or a point that you are considering. It can be a human being. It can be some other thing as well.
Thank you, ma'am.
Okay, I guess. Anyone else, if you are having any doubt, or else I'll just. I'll just end the class. Okay, so I guess you guys don't have any doubts. So maybe we can end the class now.
Thank you very much, ma'am.
Okay, okay. See you guys. Take care. See you next week.
जल्दी जाना 5 बजे।
Thank you, ma'am. Thank you, ma'am.
Okay, take care.